In this video, we are going to solve another problem on infinite limits and limits at infinity. For this problem, we are asked to find the limit of the function x plus the square root of the quantity x squared plus 2x minus 3 as x approaches negative infinity. Let's try direct substitution first to get the limit of the function. Recall that the limit of a sum of two functions, f of x and g of x as x approaches a, is equal to the sum of the limits of f of x and g of x as x approaches a. In this problem, let us denote f of x as x and g of x as the square root of the quantity x squared plus 2x minus 3. Therefore, the original limit can now be rewritten as the limit of x as x approaches negative infinity plus the limit of the square root of the quantity x squared plus 2x minus 3 as x approaches negative infinity. By direct substitution, we get the following expression. Notice that by direct substitution, the value infinity minus infinity was acquired. This expression is one of the known indeterminate forms. As such, we cannot get the limit of the function by applying direct substitution first. In this type of problems, where there is a square root function and taking the limit by direct substitution yields an indeterminate form, we will calculate the limit using the radical conjugates. Recall that the product of the sum and difference of two terms is equal to the difference of the squares of the two terms. We can say that the conjugate pair of the sum of the two terms is the difference of those two terms, and vice versa. Hence, if we apply this idea to our function, the radical conjugate of x plus the square root of the quantity x squared plus 2x minus 3 is x minus the square root of the quantity x squared plus 2x minus 3. Now, if we multiply our original function with its radical conjugate, the result will be the square of the first term, that is x squared, minus the square of the second term, that is the square of the square root of the quantity x squared plus 2x minus 3. It is important to note that when multiplying the radical conjugate, we should remember to divide it with the same conjugate as well, so as not to change anything to the original function. Think of it as multiplying the whole function by 1, which does not change the function at all. Simplifying the numerator, we are left with negative 2x plus 3. If we apply direct substitution now, we will still get the same indeterminate form, but in the denominator. So, we still need to find a way to eliminate the indeterminate form before applying direct substitution. To do this, we need to divide every term both in the numerator and the denominator by the highest power that is in the function. In this case, that is the square root of x squared. We know that the square root of x squared is equal to the absolute value of x. Since x is approaching negative infinity, the values of x are also negative. As such, the absolute value of x is equal to the negative x. Therefore, we divide every term in the function by negative x. Simplifying, we get the expression below. Since we said that negative x is equal to the square root of x squared, we change negative x to the square root of x squared to simplify the terms inside the square root. By the laws of exponents, we can divide x squared plus 2x minus 3 by x squared and place them inside the square root. Then we divide each term in the numerator inside the square root by x squared to get the expression below. When we apply direct substitution now, we can see that no indeterminate form is produced and we can focus on simplifying the expression. Take note that a finite value divided by infinity or negative infinity is 0 and the square of infinity is still infinity. Simplifying the expression, we get negative 1. We can verify that the limit of the function is indeed negative 1 by plugging in the function in a graphing calculator. Therefore, the limit of the function x plus the square root of the quantity x squared plus 2x minus 3 as x approaches negative infinity is indeed equal to negative 1. Thank you for watching.